Hello everyone. The title of this video is Combining Functions Using Algebraic Operations. Now every example I'm going to be doing in this video is taken directly from a free online textbook at openstacks.org, and I'm in their Algebra and Trigonometry text, section 3.4, titled Composition of Functions, and I'm under the heading Combining Functions Using Algebraic Operations. Now each example I'm doing is going to be either an example from the reading or one of the try it problems from the reading or one of the exercises at the end of the section in the reading here. Alright, so let's get to it. Alright, so I have my first examples written out by hand here on a piece of paper, and the instructions we're given for each of these examples is 1. Find and simplify the function that they're asking us for, and then 2. Write the domain of the function in interval notation. Alright, so this video is about using algebraic operations. That's adding, subtracting, multiplying, and dividing functions. So this is actually, I feel, pretty simple. You're given in the beginning here. So in example 1, see I'm given two functions, one named f, right, f of x, and another one named g, right, or g of x. F of x is x minus 1, right, that's how you calculate outputs for function f given input x. And g of x is x squared minus 1. Right, so again, here's how you calculate the output given input x for this function called g. And what we're asked to do in parts A, B, C, and D is take these two original functions and create a new one, a totally different function. But they're taking the names of the original two and just telling you how to form the new function they want. So for example here, part A, they're asking us to create a new function called f plus g. Now you could call it something else if you want, call it h, call it sum, whatever you want, but this tells us immediately what we're going to be doing with functions f and g. We're going to be adding them. Right? And another way to write this would be, this function called f plus g of x is exactly that. It's whatever the output for f of x is plus whatever the output for g of x is. It's as simple as that. So I replace f of x here with the quantity x minus 1. There's f of x plus, then g of x is x squared minus 1. And really I don't need the parentheses around these because they're not being multiplied or raised to powers or subtracted, right? Just addition here. Then I combine like terms, and I like writing my polynomials in descending order, so the highest powered of any of these terms is x squared, and there's no other x squared term to combine that with. Then there's a positive x to the first, right, plus x. And then we have negative 1 here plus negative 1 here. That would be negative 2. Right? And there we go. Right? This is what we're asked for in part 1. Right? Find and simplify the function. So this is a new function called f plus g, right? Or the sum of f and g. You take the output of f plus the output of g, and it makes this wholly new function here. Y equals x squared plus x minus 2. Very, very easy, in my opinion. And then part 2, we're asked to write, the domain of this function in interval notation. Now the domain of this function, there are no denominators with variables anywhere in this problem. There are no even roots of an expression with variables, square roots, fourth roots, sixth roots, etc. There are no logarithms, which you may or may not know about. But yeah, so if that's the case, the domain is all real numbers. We can plug in anything we wish for x here, and you will get a real number output. And the interval notation for all real numbers, if you recall, hopefully from a previous video on interval notation, is negative infinity to infinity. Right? So that's the second part of these questions. Right? State the domain. What's allowed to be plugged in for x? Wonderful. All right, so that's part A. Part B is the same kind of problem. We're taking functions f and g and creating a new function called f minus g. And it's exactly as it sounds. You're taking the output from f and subtracting the output from g, right? So another way I could write this would be take f of x and then subtract g of x. Now the output for f was x minus 1. There's f of x. Minus, and then the quantity, right, the output for g was x squared minus 1. Now here I'm going to need the parentheses to stay there, because we are subtracting, and you got to be careful. You're not just subtracting x squared, right? You're not just subtracting the first term of g. You're subtracting all the terms of g, right? The entire function g of x. So I'm subtracting the x squared and subtracting negative 1. So when all's said and done here, I'll have a minus 1x squared, and I'll put that first, highest powered terms first. You still have this positive 1x, and that's it. Because here you have negative 1, but then you'll be subtracting negative 1, or adding 1. Negative 1 plus 1 will be 0, so there is no constant term, or there's a constant term of 0 for the final result of this function when simplified. Alright, so the function f minus g of x is negative 1 times x squared plus x. That's how you calculate the output when you subtract the outputs from f and g. And once again, the domain is very simple. It's all real numbers, right? Nowhere throughout this entire problem here was there a denominator that could possibly be 0. There were no even roots, no logarithms, right? So once again, the domain of this new function called f minus g is all real numbers, right? From negative infinity to infinity on the real number line. You can plug in anything you want for x and get a real number output. Wonderful. All right, part C. F times g. See, it's just fg. Right? So we're taking these original functions f and g and creating a new function called fg, or f times g. And it's exactly as it sounds. We're going to take the output from f, right? Take f of x and multiply by the output of g, right? F times g. So these are the same thing here. Alright, so the output from f was, the quantity x minus 1 times, and then the output from g, the function g, is x squared minus 1. And then I'm going to do a bunch of distributing, right? You distribute, you FOIL, right? You take x times the x squared minus 1, and then negative 1 times the x squared minus 1, and combine like terms, if there are any like terms. So x times x squared minus 1, that'd be x cubed minus x. And then negative 1 times x squared minus 1 would be minus x squared plus 1. Right? And then I'll rearrange it so that they're in descending order. So we have x to the third power, minus x squared minus x plus 1. There you go. And that's the final result. It's as simplified as that's getting. Great. So there's this new function, the calculation of the output for this new function fg, or f times g. Very easy. And once again, the domain of this function is all real numbers. There are no denominators that could be 0. There are no even roots of variables, variable expressions. So in interval notation, once again, that's from negative infinity to infinity, right, with parentheses on the ends. Okay. All right. And then the last one here, part D, for example 1. We're taking these two functions, f and g, and creating a new function called f divided by g, or f over g, or whatever you want. Right. That means that you're taking the ratio of f and g. And again, it's telling you what to do. You take the output from f and divide it by the output from g. Right? So these are the same expression here. Both these mean the same thing. So f, the numerator, will be x minus 1. The denominator is x squared minus 1. Alright, now here's where we're going to have some domain problems. Remember, the denominator can't be 0. So x can't be positive or negative 1. Right, because if x were 1 or negative 1, this denominator would be 0, and you can't have a denominator of 0 throughout the entire problem. Right? So x can be anything but 1 or negative 1. So in interval notation, that's from negative infinity up to negative 1, but not including negative 1. Then you have a break, a union, and then you have every number from negative 1 to positive 1. Right? You can use any of those numbers, but again, parentheses on those. And then a union again, another break, and then from 1 to infinity, right? Anything greater than 1 can also be used, but parentheses on 1 again. Alright, so there's the domain. Now we haven't totally simplified the function yet. Alright, because you can factor, remember how to simplify a fraction. The numerator can't be factored anymore, that's just x minus 1. But the denominator is, a difference of squares. That's x plus 1 times x minus 1. And you can very clearly see now that x can't be negative 1 or positive 1. Right? So the domain has to be all real numbers except for negative 1 or positive 1. But now I'm also seeing some cancellation. You see this factor of x minus 1 in the numerator and denominator. Those will become 1. And we get our simplified function 1 over x plus 1 in the denominator, and that's it. Alright, that's as simple as that's getting. Okay. Great. And again, you can plug in any number you want for x, just not 1 or negative 1, because that will make you divide by 0 somewhere in this problem. And you can't divide by 0, right? That's undefined. Great. And again, easy as this stuff, just take, we're going to do the same for all the examples I have in the rest of the video. We're going to be given two functions called f and g, and asked to add them, subtract them, multiply them, or divide them, and then state the domain. Now the only ones you really have to be careful of, pay attention to, are the subtraction and division problems. Because remember, the order matters when you subtract, right? F minus g is the opposite of g minus f. Those are totally different. And same thing for f divided by g. That's the reciprocal of g divided by f. So if you have f divided by g or g divided by f, those are totally different functions. But addition and multiplication doesn't matter. F plus g is the same as g plus f. F times g is the same as g times f. So the only ones you really have to pay attention to are f minus g and f divided by g. Subtraction and division. Order matters in those cases. Okay. All right, the next example is very, very similar, right? We're given two polynomial functions here, it looks like. F of x is negative 3x squared plus x. G of x is 5, right? A constant function. The output's always 5 for function g. All right, and then instead of, they tell us to write, to find the same functions we found in parts A through D for example 1. So what's this function called f plus g of x? All right. And again, very simple. It's just f of x, so negative 3x squared plus x, plus, and then g of x. What's g of x? And it's just, 5. And there's nothing to do, nothing to combine here, so that's it. This is the resulting simplified function f plus g. F plus g of x would be negative 3x squared plus x plus 5. And that's how you would calculate the output for this new function called f plus g with an input of x. All right. And of course, there's no denominators here. That could possibly be 0. No even roots, no logarithms. So the domain is all real numbers, right? Everything from negative infinity to infinity. You can plug in anything you wish for x and get a real number output. All right, part B. What's taking these functions f and g? What would be the new function f minus g? What would be this function f minus g of x? And again, it's just as it says. Just take the output for f, negative 3x squared plus x, and then subtract now the output for g. Subtract 5. Well, once again, there's really nothing to do here. There's no like terms to combine. There's no, you can't really distribute the negative here because there's only one term. It's just 5. So all we're left with here is negative 3x squared plus x minus 5. And that's it. That's none of these terms go together. And we're done. And then once again, the domain is all real numbers, right? You can plug in anything you want for x and get an output for this new function called f minus g, right? So from everything from negative infinity to infinity. Right? Great. All right, what's this function f times g? All right, or fg, right? So this function fg of x, again, it's just the output of f, which is negative 3x squared plus x, multiplied by the output from g, which is simply 5 all the time. All right, now here we need to do some distributing. All right, I can distribute this 5 over these two terms here. So our final result, our simplified resulting function, be a negative 15 x squared plus 5x. And there we go. That's our function f times g of x. And once again, no denominators, no even roots, no logarithms. The domain is all real numbers. You can plug in anything you want for x and get a real number output. So from negative infinity to infinity once again. Okay. And then the last part of this example, again, f divided by g. So this new function called f divided by g of x is simply, numerator is f, negative 3x squared plus x, and the denominator is g, which is simply 5. Notice the denominator is always 5, right? The denominator will never be 0. So the domain is once again all real numbers, and this is fine here. Or you could actually divide each term by 5 and say, get negative 3/5 x squared plus 1/5 x. Either one of these is fine. I'll just circle this first one. And the domain is once again all real numbers, right? Because, yeah, there's a denominator, but it's always 5, right? It's never 0. So from negative infinity to infinity, once again, you can plug in anything you want for x and get a real number output. Okay. All right, next. All right, so now the functions we're given in number 3 are not polynomials, right? They're rational functions, fractions. So we have 1 over f of x equals, 1 over x minus 4, and g of x equals 1 over 6 minus x. So right away I'm seeing that for f anyway, x can't be 4, right? For function f, x can't be 4 because you'd have 1 divided by 0. And then for function g, x can't be 6. Just noticing that, pointing that out to myself right now. Because if you were to put in 6 for x, you'd have 1 divided by 0. And that's not good. Alright, and then we're asked for the same 4 things, right? F plus g, f minus g, f times g, and f divided by g. Alright, so once again, f plus g, very simple to make. It's just what's the output from f? 1 over x minus 4 plus, and then what's the output from g? 1 over 6 minus x. Now, you could leave it this way, but if you want to make a single fraction, you need to get a common denominator. Alright, so this would be equal to, 6 I would multiply this fraction by 6 minus x over 6 minus x plus, and then I'd multiply this fraction by x minus 4 over x minus 4, and the common denominator would be the product of x minus 4 with 6 minus x. Right? And then if you actually combine some like terms in the numerator, 6 and negative 4 make 2, and the negative x and positive x make 0. So you just have 2 in the numerator. And if you want, you can keep the denominator factored, but you can also multiply it out. I don't see any common factors it would have with the numerator. So it'd be negative x squared, and then you have negative x squared, then plus 4x plus 6x, so plus 10x, and then minus 24. And if you want to put the negative up top, you can. Make it negative 2 over x squared minus 10x plus 24. But this is it. All right, this is a simple fraction, single fraction. But the domain in interval notation is not all real numbers, right? As you see the denominators throughout this, right? The denominators are x minus 4 and 6 minus x are factors in these denominators. So x can't be 4 or 6. So we can take everything up to 4, right, from negative infinity up to 4 in union with, and then everything from 4 to 6, right, so 4 to 6 with parentheses, not using 4 or 6, and then in union with, and then everything greater than 6, right, from 6 to infinity. So there's your domain in interval notation, right, everything less than 4, between 4 and 6, greater than 6, but not 4 or 6 themselves. Okay, great. Alright, then part B, f minus g, very similar. Alright, I'll just do this time. Right, f minus g of x would be f of x, 1 over x minus 4, minus g of x, right, 1 over 6 minus x. And if you'd like, you can multiply. Now you can't multiply the numerator and denominator by this negative here, just one or the other. I'm going to do this just because I like having a positive lead coefficient instead of a negative one. This is 1 over x minus 4, and then plus 1 over x minus 6. Right, multiplying 6 minus x by negative 1 makes it x minus 6. So these are the same thing. And I'd multiply this fraction by x minus 6 over x minus 6, and this fraction by x minus 4 over x minus 4. We'd have x minus 6 plus x minus 4 in the numerator all over, and then the common denominator of the product of those two, right? X minus 4 times x minus 6. And so the numerator would be 2x minus 10. Right? We combine like terms, or 2 times the quantity x minus 5 divided by x minus 4 times x minus 6. And you could leave it like this. This is simplified. Now if you want to multiply out the denominator, you can. That'd be x squared minus 10x plus 24. But this is as simple as a fraction will get. Right? And the domain, I'll just say the domain is the same. Right? So this domain I wrote here is the domain for both these functions. Because it's, you can't plug in 4, you can't plug in 6. Same as here, right? So the domain is everything up to 4 in union with everything between 4 and 6 in union with, and then everything greater than 6. Okay, great. All right, part C is multiply them. So again, fg or f times g of x is simply that. Take f, 1 over x minus 4, times g, 1 over 6 minus x. And it's really that simple. The numerator is just 1, and the denominator is that product, negative x squared plus 10x minus 24, or if you want to put the negative up top, multiply the numerator and denominator by negative 1. It'd be negative 1 over x squared minus 10x plus 24. But still, that is a simple fraction. There's no common factor in the numerator and denominator. And the domain is the same as the previous two. It's everything less than 4, everything between 4 and 6, and everything greater than 6. But I can't use 4 and 6, right? Because you'll be dividing by 0 here. You'd be dividing by 0 here, dividing by 0. You'd be dividing by 0 in a lot of places throughout this writing here if x were 4 or if x were 6. So same domain as parts A and B. Okay, and then finally, we have f divided by g here. So what's f divided by g of x? So I take f, which is 1 over x minus 4, and then divided by g, 1 over 6 minus x. And remember, division is multiplication by the reciprocal. So this is the same thing as 1 over x minus 4 times 6 minus x over 1. Right. Division is the same as multiplication by the reciprocal. And so the numerator, 1 times 6 minus x, is just 6 minus x. The denominator, x minus 4 times 1, is just x minus 4. And these don't have any common factors. This is as simple as it gets. The resulting function is 6 minus x divided by x minus 4. And it has the same domain as all the others, because if x were 4, you'd have a denominator of 0 up here. If x were 6, you'd have a denominator of 0 here. Right? X can't be 6 in the function g. Right? So still x can't be 4 and x can't be 6. You still have the same domain as parts A, B, and C. You can only plug in values less than 4, between 4 and 6, or greater than 6, but not 4 and 6 itself. Great. And now I've got one final page, one final example with the same. Now look at this. Remember I said the subtraction and division, you got to pay attention. See how in part B, instead of doing f minus g, now I'm doing g minus f. Right? And in part D, instead of doing f divided by g, I'm doing g divided by f. And those are totally different, right? In subtraction and division, the order matters. All right. In addition and multiplication, the order doesn't matter. All right. So f of x is the square root of x, and g of x is the absolute value of x minus 3. Well, so right here, right away I'm noticing f has a square root and even root with a variable expression inside. Square root of x. So x has to be a non-negative number, right? X has to be greater than or equal to 0 in function f. Because remember, if you take the square root of a negative number, that's not real, that's imaginary. Right? We want to set up our domains so that we get real number outputs. All right, so first, f plus g of x is simply the square root of x plus the absolute value of x minus 3. It's that simple. And there's nothing to combine here. It is that easy. That is the function f plus g. And the domain of this function in interval notation, well, there is a square root as mentioned. You can only take square root of non-negative numbers and get real number outputs. So we're going to go from 0 to infinity for the values of x we can use, including 0, right? You can plug in 0, square root of 0 is 0. And then 0 minus 3 is negative 3, the absolute value of negative 3 is positive 3. You'd get an output of 3 when you plug in 0. All right, so 0 is included. I got the rectangular bracket on that, not a parenthesis. Okay. And g minus f. Right, g minus f. Again, pay attention to the order. That's g first, so the absolute value of x minus 3. And then minus f, which is just simply the square root of x. And that's it, right? There's nothing to do with these. There's nothing to combine. Very simple stuff. And the same domain. Okay, again, you got this square root of x here. Can't take square roots of negatives and get real number outputs, so x has to be 0 or greater. So same domain in part B as in part A. Wonderful. All right, then part C, f times g of x. Again, it's just f, so the square root of x, times g, the absolute value of x minus 3. And that's it. And don't distribute the square root of x. All right. I know the square root of x is a non-negative number, but let's just be safe. Don't just be safe and don't distribute over absolute value symbols unless you know you can otherwise, right? So that's it. Very, very simple. And because there's this square root of x in there and there's no denominators, this is the domain again. You can only plug in values of x 0 or greater. And then finally, again, pay attention to subtraction and division. This is g divided by f. All right, g divided by f. So the numerator is g, which is the absolute value of x minus 3. And the denominator is f, which is, the square root of x. And again, that's as simple as that's getting. Don't do anything with absolute values. Don't distribute. Don't do nothing. All right, nothing crazy. All right, now this has a different domain. All right, so I'm not going to just draw another arrow. The domain of this function, it's very similar, right? Again, I have a square root, the square root of x. So x has to be, greater than 0, right? But notice what happens. X can't be 0 here, because if you plug in 0 for x, this denominator is 0. So it's everything from 0 to infinity, but not including 0 this time. So notice I have a parentheses on 0 instead of the bracket. All right. So just a little different. All right. So it's the same domain basically, just without 0. All right. You got a parentheses on 0 instead. That's it. All right. Again, very simple stuff, I feel. f plus g or g plus f, same thing. G minus f, which is the opposite, a totally different function than f minus g. F times g, which is the same as g times f. And g divided by f, which would be the reciprocal, right? A totally different function than f divided by g. But just pay attention to how the functions are named, and you can easily form them by adding, subtracting, multiplying, or dividing. And then stating the domains is also usually pretty simple, right? Just pay attention to if you're ever dividing by 0, if you're ever going to take the even root, square root, fourth root of a negative number, you know. And then there's things called logarithms, which we'll eventually get to in future videos, but that's it. Alright, I'm hoping that watching me go through these 4 examples here help you out in some way when you're asked to combine functions using algebraic operations, addition, subtraction, multiplication, or division on your own. And thank you very much for watching.